Okay, so we got problem 4.42. It says find V naught in the circuit. I'm going to use the universal method to find the answer to this problem. And then it says calculate the power delivered by the dependent source. So we're going to look at this dependent source right here. All right, so let me go ahead and label our nodes. So I'm going to call this bottom node our ground node. All right. This would result in 10 volts. We call this our V naught, V1, 4 volts, and we're going to call this V2. Now we got to label our currents. I call this IS. Let's say 1, 2, and then this is I delta. I delta, I'm just going to call I delta equal ID. So yeah, let's go ahead and write the KCL so we know that IS equals I1 plus I2. The loop completes here, so no need to write a KCL for that. Equation for components. So we know right off the bat IS is 10 minus V naught over 2. I1 equals V naught over 16. 2 is V naught minus V1 over 12. You know that V1 minus 0 is 4ID. Now we see that ID is equal to 4 minus V2 over 5. And it's also equal to V2 over 3. V2 minus 0 over 3. So we have V1, V naught, we have V1, 2, IS, I1, I2, and I delta. So we have 7 unknowns and we have 7 equations, right? So let's go ahead and use maximum again to solve this. It's a linear system. S equals I1, I2, S equals 10 minus V naught over 2 equals V naught over 16. 2 equals V naught minus V1. V1 equals to 4 times ID. E equals minus V2 over 5 equals V2 over 3. V1, 2, S, I1, 2, D. So, yeah. So this would be our result. Okay, so, all right, so for part B, this is part A. So, oops. Part B, we want to know power delivered by the dependent source. So we know the current I2 and the voltage potential across is V1. We know that V1 is also equal to 4 times I delta. So 4 times 0.5 is 2. So yeah, I2, that looks like a -2. Yeah, I2 times V1, 1 watt. That's how much power is being delivered by the dependent source. And yeah, this is our solution.